right, so this lecture is going to be about the physical geography of Latin America. For past lectures, we have been focusing on specific topics within the world's regions. For Latin America, we will focus on the physical processes that shape the land in the vast continent that this cultural region spans through. We are focusing on physical geography because we are gonna have an interesting segment here in exploring how the land has shaped historical development. And in order for us to understand that, we also need to understand the land itself. So start here, we'll talk about two things, plate tectonics and climate, and it will be an overview of chapter 4. The beginning pages of chapter 4 and some pages of chapter 5 in regards to physical geography you'll be doing on your own as listed in your study guide. Now, as you can see here, Latin America is complex in how much is going on as far as plate tectonics. There are 7 interacting plates moving in different directions and shaping different plate boundaries. I'm going to focus on, in particular, the west coast of Latin America and looking at this very active region in the Latin American land where subduction is taking place. Let's pay a specific attention to what's going on in the Nazca Plate and realize that that same subduction is witnessed also between the Cocos Plate and the Caribbean Plate, and also the Antarctic Plate and the South American Plate. So let's take a look at an interesting video that I found.
The Circum-Pacific region is defined by subduction zone plate boundaries that produce 80% of earthquakes worldwide and have over 400 active volcanoes, earning it the title Pacific Ring of Fire. More than 1/4 of the world's great magnitude 8 or larger earthquakes have occurred in western South America. It is home to the 1960 magnitude 9.5 Chile megathrust earthquake, the largest earthquake ever recorded, and to an array of earthquakes generated by plate boundary and intraplate tectonic processes. Regional tectonics are dominated by subduction of the oceanic Nazca Plate beneath the continental South American Plate, which produced both the 5,900-kilometer-long Peru-Chile Trench and the arc of active volcanoes parallel to the trench. Rates of convergence range from 5.6 centimeters per year in Ecuador to 6.3 centimeters a year in northern Chile. They have recently been updated using GPS observations.
So as you see here, this large subduction zone between the Nazca and the South American plates generates in a lot of earthquakes and volcanic activity. Now let's take a look at these hazards in South America that are also present in this subduction zone here and in the southern tip of South America, which is earthquakes. Let's take a look at USGS, which records the most recent earthquakes. And here we are. If you have not been to this website before, it is very interesting in that it has live data about tectonic activity in the world. Now let's take a look at the last 30 days with magnitude 4.5 or more, and let's organize our data here with the largest magnitude earthquake cited here first, and look at what we find. Guatemala here a couple of days ago with a 6.9, and San Jose, also Guatemala, at 6.8, okay? And how that west coast of Latin America has experienced a lot of earthquakes recently, showing you that this is a tectonically active region of the world. Now, it is tectonically active, but it is also, Western South America and Central America here is also a subduction zone, which is part of the global ring of fire. This is where most of the world's volcanoes are taking place. And it is also here that we see a long volcanic mountain range, right? So do you know the name of this mountain range? This is the Andes. And the Andes are, a glorious mountain range with peaks as high as 23 plus thousand feet. Mount Aconcagua is an example of that. That are active. So South America alone has over 100 active volcanoes along the Andes Mountains. Now the Andes, for those of you that have not had a chance to see it in person or maybe even in pictures, here is a beautiful National Geographic article depicting a journey through the Andes. It is an extremely important physical feature of the world, an imposing spine of mountains, but also it is an important cultural feature of Latin America, where indigenous people have thousands of years of history in the Andes, and you can kind of see how the Andes changes in extent, in volcanic activity, and in peaks all throughout its span in South America. Now here's Mount Aconcagua. This is the highest peak in the Andes Mountains and in the Americas. So 22,835 feet is the exact number here. And it is found right here between the Chilean and Argentinian border. Now the Andes, aside from being a glorious physical feature, is an important cultural feature of Latin America, as millions of people live here until this day, but also where an ancient civilization, the Inca, thrived, and where the descendants of the Inca live until this day. Later on, we're going to talk about the mastery of the Inca of the Andean environment and the limitations and opportunities that the Andes brought to the Inca. Now, the Inca had a very interesting relationship with the volcanoes of the Andes, in that they found the volcanoes to be these sacred places. Human sacrifice was a prominent characteristic of indigenous Americas, and the Inca tended to, differently from the Aztec and the Mayan, tended to sacrifice the children of the elite, like it was an honorable thing to do, to the gods, in order to appease the gods to rule nature in their favor. Here's a picture of a mummy that was recently recovered. I think she was recovered in the 90s, when a gaseous spew from one of the volcanoes in Peru released ice blocks where the Juanita mummy was frozen, and scientists, archaeologists are rushing to see what they would find in these ice blocks that had been released from a gaseous eruption, and they ended up recovering about 5 mummies of Inca children, and Juanita is one of them. She's incredibly well preserved, as you can see, because of the dry environment of the Andes and the colder temperatures. Volcanic activity is found within the western coast of Latin America, where the subductions are. They're prevalent there. There are some other places where volcanoes are found. We won't talk about that, but the general pattern is within the western Latin American extension. Here in Central America and Mexico, the volcanic distribution is a byproduct of the Cocos Plate subducting underneath the Caribbean Plate, resulting in the volcanoes of Mesa Central, in Mexico, where Mexico City is, and the Central American volcanic axis. It is here in Guatemala that we find the highest volcanic density in the world, meaning that there are more volcanoes per square kilometer here than anywhere else. And volcanic eruptions can be massive. This one is a 2011 eruption that happened in Chile. And you can see how it impacted the air quality for a while there. You know, the gaseous materials that were released into the atmosphere kept not only air quality for visibility, you know, in airplanes were stranded in airports, but also a lot of risk for respiratory problems. So how does this tectonic activity shape the landscape? Well, certainly these volcanic mountain ranges that are found throughout Latin America, we can see here, these are those volcanic mountain ranges of the Central Valley of Mexico, and running down through Central America and the volcanic axis, and then beginning a new South American volcanic mountain range, which is the Andes. The Andes are remarkable physical features, as we talked about. You can see here in Colombia, where it breaks down into 3 cordilleras or 3 mountain ranges. And later on, we're going to be talking about how important this is for the historical development of Latin America, how this physical barrier for diffusion impacted the connectivity of American indigenous peoples. But looking here, you can see from this satellite image the contrast of the east to the west, how the west is very active with these active peaks of the Andes. This is where ice builds up and melts to trickle down to contribute to the largest river in the world, the Amazon, that is born in the Andes, and that trickle down, you know, that drainage system of the highlands to lowlands is going to contribute to 200 tributaries that will eventually feed the most voluminous river in the world and discharge its waters in the Atlantic. Here in this image, you can see just how wide the Andes get, in particular in Colombia here, where a plateau called the Altiplano, it takes, you know, a major portion of Bolivia, and is also an important physical feature of the Inca Empire, which we'll talk about later. This image here contrasts the east coast to the west coast, and you can kind of see the eroding landscapes of the east, where the common landform will be these rounded, eroding hills and mountains versus the very active parts of the Andes, contrasting landscapes, and how the Andes go all the way down to the fjords of Chile, where they will look like mountains in the middle of the ocean because of glaciation processes that flood the valleys, and eventually end in the southernmost tip of South America, Tierra del Fuego. So the second important dimension about the physical geography of Latin America is the diversity of climates that the region experiences. Spanning through so many different degrees of latitude, it also spans through many climatic belts. I am currently tapping on to your knowledge from chapter 2. If this looks too foreign to you, then you should probably reread chapter 2 and get a refresher on basic physical geography. But what you're looking at here is a map of the Köppen climate classification system in the context of Latin America, telling you just how many different climate regions occur in Latin America. So as the stereotype follows, Latin America is this vast land of jungle, right? Well, almost. It does have a large land area of tropical climates, but as you can see here, it is more complicated and diverse than that. We certainly have vast rainforests, right, found in these warm and wet places of the tropics. This one being the largest rainforest in the world, the Amazon, which we'll talk about later, or maybe another place that you associate with the rainforest here, which is Costa Rica, right? So Central America and Equatorial South America, yes, are home to rainforests. But also, what you may have not associated with Latin America before is the fact that Latin America also has a lot of deserts, right? Certainly, northern Mexico is probably not surprising to you based, the proximity to California. That's probably the image that you have of Mexico. But perhaps what it may be surprising to you is that South America is home to the driest desert in the world. And this coastal desert here, the Atacama Desert, is in the same latitude right here in its Peru extent, is in the same latitude as the Amazon. What is happening here, right? How can the driest desert in the world happen in a climatic belt that coincides with the world's tropical rainforests? Well, this has to do with a phenomenon that you should have read about in chapter 2, which is the rain shadow effect. What is the rain shadow effect? The rain shadow effect, or orographic precipitation, is essentially the role that mountains play in regional climates and local climates because of the physical barrier that mountains can be to moving air masses. So for example, in South America, there is an air mass that runs through the 0 degree to the 30 degrees south latitude, which is the southeast trade winds that blow through the Amazon, blow through a moist region. Water is taken from the vegetation and evaporates, meaning that this is a warm, moisture-carrying air mass that is moving towards the Andes. This can be seen right here. So here are the trade winds moving these air masses, right, towards the Andes mountains. As they do that, the air is forced to rise. As it rises, it cools. As it cools, it loses ability to hold moisture, leaving the other side of the mountain dry. So the windward side of Peru is wet, and it is where the Peruvian Amazon is found. And the leeward side of Peru is in the rain shadow of the Andes, and it is where cities like Lima, which are dry cities, are found. So this can be seen here. So Lima is located in the rain shadow of the Andes, and Lima has very little precipitation throughout the year because of it. But there's a second factor at play as well. You may be asking yourself, this is a coastal desert. Why is it not getting moisture from the ocean? This ocean should be a tropical ocean, being that it is within tropical latitudes, but reality is it is not. The water in the Pacific, in the coast of Peru here in Chile, is actually cold water because the current that dominates this region here, the Humboldt Current, is a cold oceanic current. Cold water does not result in evaporation. Therefore, the adjacent air masses to this ocean are dry. So the Atacama Desert is a byproduct of the rain shadow effect of the Andes Mountains, and it is a byproduct of the effect of the cold Humboldt Current. Other climates are also found in Latin America, like mild climates and highland climates, and in particular, we will be talking about the role of this high topography in the historical development of the Inca. So let me take you to Google Earth, to this vast region of the world. And here are some of the pictures that should, inspire some curiosity of the mystery of a civilization that dominated such complex environment. And here is a picture of Machu Picchu in the Andes, famous Machu Picchu, and how you can see how the Andes interacts with that, the incoming air masses, the tremendous topography, the incredibly tectonically active region here. And just to close this lecture, just to remind you that Latin America is extremely diverse in its topography. It is extremely active. It is extremely diverse in its climates. It is extremely diverse in its peoples. But for this segment and this lesson, we're going to be focused on how the geography and this lay of the land set opportunities and limitations for the Inca that enabled the Spaniards to conquer such a vast empire.